Bismillah. What's going on, guys? Assalamu alaikum. Welcome to Amigoscode. In this course, I'm going to teach you everything you need to know about Java. Oops. I want to teach you everything you need to know about Java data structures. So data structures is pretty much a way for us to organize and manipulate data. And Java has, various different classes available to us that we should be aware and how they work. So this was because you guys have been requesting that I should basically explain all of these different data structures that the Java language has to offer. So there you have it. If you're new to my channel, go ahead and literally just take 2 seconds, like literally 1, 2, and smash that like button so I can keep on recording videos and courses like this. If you're not part of the Amigoscode community, go ahead and join. Also, the Discord is being really active, so go ahead and join there. Private Facebook group is growing as well. And yeah, also let me know what you want to see next. But I do have lots of awesome content coming, so make sure to subscribe if you haven't done so. Without further ado, let's kick off this course. All right, so let me go ahead and create a new project just for data structures where you can have the source code on Git. So in here, I'm inside of IntelliJ, and if you want to install IntelliJ, you can download using Toolbox. So this is how I basically manage all my IDEs provided by JetBrains. So in here, I'm going to create a new project. And in here, let me pick a Maven project. And for the project SDK, I've got 17 installed. But if you want to basically choose any other version or even download any other version, you can do so by saying download, and then you can pick the version that you want in here. But in my case, I'm going to stick with the latest version as I speak, which is 17. But everything that you'll learn here, it will apply to pretty much all versions of Java. So here, let me just cancel, and don't create from an archetype. Just say next. And then pick a project name. So Java data structures. And let me also store this in my desktop. There we go. And for the artifacts coordinates in here, you can say, for example, com.amigoscode. And then the name of the artifact. Leave everything as default. Just give it a second. Okie dokie. So all good. Now, this is a Maven project, so you can see src, main, Java sources, resources, and then tests, so on and so forth. So we're not going to focus on testing, but we're going to basically create all the examples under this folder right here called Java. So what I want to do is I want to create a new package here, and I'm going to say com.amigos and then code. So make sure that this is your domain. Press enter, and there we go. Next, let me go ahead and start with arrays. All right, so before we actually start learning about the collections framework, what I want to teach you is arrays. So we're going to learn first about arrays and 2D arrays, because knowing how to use these, moving forward, you'll see that arrays are building blocks of many other data structures that Java has to offer. So what is an array? So basically an array, you can think of it as basically a list of cells or a bucket or list of buckets where you define the size. Now, when you define the size is fixed. So here we've got an array of 5 elements. So it can only have 5 elements and the size is 5. Now the index for the array, so this is how you access an element inside of your array. The index starts with 0 right here. So this is the 0 index, 1 index, 2 index, 3 index, 4 index, right? So basically if you want to access, for example, this blue let's say item inside of this cell, you refer to it as, so the array name and then the index 1, and then it will give you this element in here. Now arrays are really fast for data retrieval because you kind of just basically define the data structure or the array itself. And then if you want to access a particular element, it basically just needs to know where it is in memory, and it doesn't have to do any computation. So later when you learn about, big O notation, so for you to retrieve a element from an array is just O of n, right? So it's really fast. So it's compact for memory usage if the size is known. Delete operation though, it's a little bit hard, because if you want to, for example, delete, let's say that this is here, right? So if you want to delete this element and you have a bunch of other elements here, you kind of have to basically make sure that you kind of bring or reshuffle everything so that you leave the array with some extra space. So there isn't like a delete method on arrays, so this is something that you have to implement yourself, but delete is hard. And also arrays, or basically arrays actually, they are the building blocks for 2D arrays that you're going to learn later. Next, let me go ahead and show you how to work with arrays. All right, let me go ahead and create in here a class, and I'm going to name this the, and then arrays. This is because there's already a class called arrays, so I don't want to have any conflicts with any classes that Java provides. So here I'm going to press enter, and I'm going to have a main method, and this is where we're going to have all the examples. To create an array, you basically have to specify the data type. So here, let's say that I want to store integers, and then you need to specify these brackets. So this tells it that it's an array. Now here I'm going to have an array of numbers equals 2, or in fact, let's just say array of strings. So here I'm going to say colors, or colors, depending if you are in UK or US. So here, now we initialize this by saying new, and then string, and then the array. Now inside, we have to specify the number of elements that this array can hold, the capacity. So here, let's just say 5. There we go. So now we have an empty array that has 5 spaces. So if you take this example in here, we have this array that has 5 spaces, where currently there's nothing inside at index 0, 1, 2, 3, and 4. So inside, so now inside of this array, in order for us to add an element inside, we have to say colors, we will refer to it, and then we basically tell it to which index that we want to add the color. So here I'm going to say index 0 equals to, and then purple. And here I'm going to say index, and then this will be blue. So index 1, and then we have the blue color in here. So index 0 contains purple, index 1 contains blue. So if you want to see the array, so if you want to see the contents for your array, you might be tempted to say south and then colors. And if I just run this for the first time in here, you'll see that this gives me basically this random string right here. And that's because in order for you to print the array, so if you want to see the contents, there is this helper method in here. So say arrays dot and then to string, and then you pass your array. So this is why I didn't want to use the class, so this class, as arrays, because there's already a class called arrays that gives me a bunch of static methods. So now I can basically run, and you'll see that it will take the array and stringify it. So have a look. So we have purple and blue, so index 0 and index 1. Now here you can see that the rest are null, and this is because we haven't specified any values for these indexes. So if I collapse this, if you want to access an element at a particular index, you could just say, so here let me just say south, and I can say colors and then square brackets, and then pass the index that I want. Now this index is very important, right? So arrays index start from 0. So if I say -1 in here, this is not a valid index. And also, so let me just run this. I want to show you something. So you see that we have here purple. Now, if I take this and then say 1, and let me just do this 2, 3, and then 4. So this indeed does work right here, because you know that our array has 5 elements inside. Now, you might be tempted to do this. So 5, right? So index 5. But this will give us an error because we haven't got anything inside of that index. And in fact, it doesn't even exist. So you can see that IntelliJ is telling me array index is out of bounds. So always remember, arrays start from 0. So the 0 index corresponds to the first element. The first index corresponds to the second element, so on and so forth. So if I run this, I just want to show you the error. So you see that I'm not lying. There we go. This is an error. So here, this does not work. So if I get rid of that, and also if you want to change the basically value, you could just reassign. So you could say colors, and then at index, and then let's say 2, because currently it's null. So here I'm going to say yellow, for example. There we go. And if I basically take this line and then paste it here, and you should see that now index 3 or 2, my bad. See, I got confused there. So this is 0, 1, and then 2 now is yellow. So let me just collapse this. Now, if you know the number of elements that your array will have, then instead of having to define the array like this, you can do this way. So here, this is the shorter way of you doing things. So here, let's have another array. I'm going to say int. This will be an array of numbers. So numbers equals 2. And instead of saying new int, and then say that I'm only going to have 2 numbers, and then say numbers, and you can see that this is long-winded. This will be number, let's say 100, and this will be index 1, and let's say that we have 200, right? So you can see that this is long-winded. So instead, what we can do is we can replace all of this with curly brackets, and then just say 100 and 200, and then get rid of this. So this is when you know the elements that your array will have. Now, what you have to bear in mind is once you define the array, you are no longer able to change the size. Now, how do you loop through your arrays? So that's a very good question. So there are a couple of ways that you could loop through arrays, and they are. So let's start with the traditional for loop, which is for, and then I equals to 0. So we start at index 0, and we're going to loop while the I index or I variable is less than colors.length, and then we increment I. At this point, we could just say south and then print the color. And right here, I need to access the index as you've seen. So I just say I. If I run this, there we go. So you can see that we have purple, blue, yellow, null, null. If you want to have this loop in reverse, you could just say for I equals to colors dot length, and then here instead of I, basically this will be greater or equal to 0, and then you say I minus minus. Now you have to be really careful because in here, so colors dot length, this will give you 5, and as I said, right, indexes arrays start from 0. So here I need to deduct 1. And now if I run this, you should see that the second loop, right? So this one here starts in reverse. So null, null, yellow, blue, and then purple. So let me actually show you. So here, if you want to know the length of your array, you could just say south and then colors dot, and then it has a length property that you can access in here. So this is the length of your array and not the numbers inside of the array, right? Because if you have no values, then this will basically count them. It's just the size of your array. Now, the other way that you can loop through, so let me just put this right here. So the other way that you can loop is by using the enhanced for loop. So it goes like this. You say for, and you say the data type for your elements inside of the array is a string. You assign a variable. In JavaScript, you'd say in, and then colors, for example. But in Java, you just say column in here. And then here, this is the same thing. So south and then color. There we go. And yet another way is by using arrays dot and then stream. And here I'm going to say colors dot for each. And this takes a consumer system dot out column print line. So this is method reference. So this is enhanced for loop, and this is using streams. And for each, maybe this is very familiar if you come from JavaScript, for example. But this is one way, second way, and the third way that you can loop through arrays. If I run this, there we go. You can see that we have things working. Now, one utility class that you should be aware is arrays. So arrays from .util. So if I press enter, have a look. You have stream, you have fill. You can fill the array. ToString, as you've seen, as list. If you want to convert an array to list. If you want to use binary search on your array. So if you want to search for an element, you can compare, copy range, check whether two arrays are equals, mismatch, parallel sort. You can sort your array, split iterator, so on and so forth. So be aware of this class because it has lots of utility methods. And also one thing that I think I forgot is that, oops, we don't need this guy here. So I forgot to mention that arrays, they come from this package right here. So java.util.arrays. So if I just click on this class and then click on this icon in here in IntelliJ, it brings me directly into this package util, and you can see arrays in here, and you can basically go and see how things are implemented. So if I show you the structure here and collapse this, have a look. So these are all the methods within arrays. So if you have any questions on arrays, please do let me know. Otherwise, let's move on. Oh, right. Let me teach you about 2D arrays. So you know about arrays, how they work. What exactly is a 2D array? Now, a 2D array is, you can think of it as basically a bunch of cells right here, right? So if I was to take basically all of these cells, so this one, and then just left with this one. So this is a array. So this is an array basically that you've learned, right? Now, a 2D array is basically dimensional. So on the y-axis and x-axis, basically, right? So it goes up and down. And you can think of it as, if you want to build applications that make usage of a grid, then you should use 2D arrays. Now, the indexes work a little bit different. So here you see that 0, 0 corresponds to this one, and then 0, 1 corresponds to the second one, 0, 2, this one. And then as you move downwards, so the y position here so becomes 1. So here becomes 1, and then 2, and you can see this is 1, 1, because so this is the second row, and then the second column, so 1, 1, right? And the same for the rest. Now, let's say that you want to build a tic-tac-toe game, for example, right? So 2D arrays is the perfect scenario. Or maybe Minesweeper, I think that's the name, is also using 2D arrays, and a bunch of other games that you can build with 2D arrays. Let me go ahead and show you this in code. So in here, I do have this file called working with 2D arrays, and let's go ahead and basically build our board for our tic-tac-toe game. So here, let's say that we want an array or a 2D array of characters. So have these square brackets twice. So you saw that with arrays, you just have one. So just like that, but with 2D arrays, you say 2 square brackets. Then here you give it a name equals to new, and then basically the initialization is the exact same thing. So 3 and 3. So this is how big the 2D array is. Now let's go ahead and fill this array. So let's say 4, and here I'm going to say int I equals to 0, I is less than 3, and then I plus plus. And inside, I'm going to have yet another for loop in here, and this will be for j, while j is less than 3, just like so, and you can see that IntelliJ gave me auto completion. At this point, if I want to fill the board, I can just say board, and then I, and also j, and here I'm going to say that the default value for now will be single quotes and then dash, just like that. So if I basically format things, and basically what we have now is, so we kind of basically filled the array with these empty dashes in here by having 2 nested loops. So if I had just one loop, I would just be able to loop through one single array, but here we have a 2D array. Now let's go ahead and print the array. So in here you saw that with arrays we can basically just see the contents by saying arrays dot to string, but here, because this is a 2D array, we have to say deep. So deep to string, and then pass the 2D array. So in our case, board. Now if I run this, there we go. So you can see that this is our 2D array. So this is the array outside, and inside we have more arrays in here, right? So this is a 2-dimensional array. Now what I want to do is I want to show you how to basically set this winning player in here, and basically all we have to do is just set these indexes right here. So 0 and then 1 0 and then 2 0. So these are the indexes for the corresponding cells. So if you were to have, for example, a winner this way, the cells would look different, right? So it would be 0 0 1 1 and then 2 2. So before I print, if I in here say board, and then I want to change the cell at 0 and then 0 equals to, and then this will be the character, and then duplicate this, and this will be 0 and then 1 and then 0 and then 2, and then this will be 1 0, this will be 2 and then 0. Now at this point, this is basically this scenario in here. So obviously I'm not filling these, but you can see how it works. So if I run this again, you should see that basically we don't have the exact same representation in here, but you can see that now we have the values for our 2D array. So 0 0 0, and then the rest are empty. And to be honest, because you know how to work with arrays, then basically 2D arrays work the exact same way. But the only difference is just when you basically loop through them. Now, what I want to show you also is if you want to inline create the array, you could just say as follows. So here, let's just have a second board, and then 2, and then I can say new, and then basically char array like so. And instead of specifying the size, inside here, I can now have the default value. So I can say new and then char, and this is basically an array. So you've seen this, right? So here, this will be dash, comma, single quotes, dash, single quotes, and then dash in here, comma, duplicate this, and there we go. Have a look. So this now is our board. And now this board right here is the exact same thing as the above, but we just have the default values instead of filling it with a nested loop. So here, if I just format things, and the board that we had was, I think it was 0 0 and then 0, or oh, my bad. So there we go. So now if I basically just loop board and then 2, you should see that this will be the exact same output. If I run this, have a look. We have the exact same board in here, but the way that I basically constructed this one was a little bit different. So obviously we're not implementing the full tic-tac-toe game, but I just want to show you how to work with 2D arrays. So basically, anytime that you want to have a grid, use 2D arrays. So you know about arrays and 2D arrays. Now let me introduce you to the list interface. Now, if you recall, so you've got the iterable interface, then you've got the collection interface, and then from the collection interface, you've got various different implementations, right? Such as the list, which we are learning about. Now, the difference between the collection and the list is that the collection interface has details. Basically, it's just a collection. Just think of it as a collection, right? So you can add stuff into it, you can remove stuff into it, and basically just a collection of elements. Now, the list itself has way more information on how to perform certain operations with your collection or your list, right? So if you want to delete at a particular index or retrieve at a particular index, then the list has basically that functionality, which any concrete class that implements the list interface knows how to do it. So you've got basically the implementations, you've got ArrayList, you've got stack, you've got vectors and others, and all of these, they differ the way that you access the elements. So that's basically it. So the list allows duplicates, is not fixed in size like arrays, is very fast for data retrievals, and so that you know, a list is backed by an array, right? So this is why I was saying that the array is basically the building blocks. Let me go ahead and demonstrate that to you in code. All right, in order for us to use lists in Java, it's as follows. Let's just say list, and in here, let's just give it a name. So in my case, I'm going to say colors equals to, and let me just import list. So this comes from java.util, and there we go. So you can see the import right here. Now with list, so this is the interface, and we have multiple implementations. If I say new and then shift control and then space, you can see all of these different implementations in here, right? So here the most famous is ArrayList, and it goes like that. So this is now our list. Now, if you want to add a value to your list, you just say colors dot and then add. So here, let's just say that we want to add the color blue, and we also want to add the color and then purple. Now, this array list itself, it's backed by an array, and I'm going to show you this in a second. So the way you access an element by the index, you can also do it in here. Now, what I want to show you is in here, if I say colors dot and then add and then 1, so this works right here. Colors dot add new and then object, this also works. Now, when working with lists, we should basically tell it which data type that we want our lists to hold, right? So the elements itself, because it doesn't really make sense for you to have array lists or lists with a bunch of different types. So to fix this, you use these diamonds right here, and then you say that here I should only have strings in my array, and you can see that all of this now goes away. And I also need to have the diamonds on this side, and I'll show you what this means in a second. So here now you can see that I cannot add the number 1 or also this object in here, so I can only add strings into my array. So there we go. Now if I want to print the array, I could just say south and then colors, and then run this, right click, run, and have a look. So we have an array with 2 elements. Now if I add a third one, so here if I say yellow and then run this, you should see that we have 3 elements. In yellow is right here. If you want to know the size of it, you could just say south and then colors, so the name of your list, dot and then size. If you want to check whether it contains, so contains right here, if it contains an element, let's just say yellow And let's check if it contains pink as well. Run this. You can see that the size is true. It contains yellow, but it doesn't contain blue right here. So the API, it's really straightforward to use, and it should be really self-explanatory. If you want to loop through your array, you have the for loop. So here you say string. So this is the data type of the elements inside of your list. And then here I'm going to say color. So this is the name of the variable, and then column, and then colors, the variable name. And now I could just say south and then color. There we go. You can also loop using the for each. So here I'm going to say colors dot for each, and this time we don't have to say stream, and I could say system dot out column print line. And finally, so I just want to show you that also if you want to loop using the traditional for I loop, you can do it. So here I'm going to say for I 0, I is less than, and we know the size, so colors dot size. And in here I could just say south, and then I can say colors dot get, and then have a look, index, and then I can pass I inside. So 3 ways that you can loop through lists. But to be honest, I wouldn't use this one here unless you need access to the index itself. So here, if I run this, you can see that all of this works. Now let's tackle this, basically the diamonds, and also let me show you the list interface. So if I click on this list interface right here, so you can see the keyboard shortcut down below, and this is an interface, and then list basically extends collection in here. But have a look, list and then diamond E. So this is using generics right here. So this is using type, and basically it's the type parameter. And if you're not really sure about generics, I've got a complete course teaching everything you need to know about generics. So I would highly recommend you for you to go and learn. So basically this is the interface. And then if I click on this eye icon, I can see all of the implementations. So have a look, including ArrayList. So ArrayList is one implementation. So if I click on ArrayList right here, so this is the class that in here we said new and then ArrayList. So let's just have a look at this class. So I want to show you that. Have a look, the default capacity is 10. And then what's more important is, have a look, object and then element data. So this is an array. So array buffer into which the elements of the array lists are stored. So basically the array list is backed by an array. And have a look. So this is the constructor, how it gets initialized, and it says new object because we work with generics in here. But what I want to show you is there is a method. So if I click on structure and have a look, grow, there is a method called grow. And all grow does is, so in here, it uses the arrays.copy element data with the new capacity right here. So basically array lists, they use arrays under the hood. So I'll let you go and explore this class. But one last thing that I want to show you is if I collapse lists, and what I want to show you is, you see in here where we say list equals to new array list. Now it is absolutely fine for you to say array list equals to new list. But the problem here is that if you want to basically switch implementation, then you'll have breaking changes, right? Because you'll be referencing array list type throughout your code, whereas instead you could basically just say list, and then it doesn't matter whether it's an array list or any other implementation. So here, let's just say new, and maybe let's just say linked list in here. And you can see that things still work. So the add method works, the size works, contains work, the loop, everything works. And that's because this satisfies the contract for the list implementation. So obviously we're not learning about linked lists, that's going to be later, but always use the interface type, and then basically you choose the concrete implementation, in which in our case it's array list. Now, just to be clear, array lists is basically the data structures that you're going to be using, I would say maybe 90% of the time. So you're going to be using array lists. And this is because memory these days is not a concern. Again, memory these days is not a concern, right? If you need more resources, you can spin up more virtual machines on the cloud where things run these days. One last thing I want to show you is, so if you want to basically construct, so a list right here, let's just say list dot. So the list class has useful methods. So here, have a look, list of and copy. But basically, if you want to have a list, you could just say list of, and then instead of saying add blue, add purple, add yellow, you could just pass the elements like so. So blue and then yellow, so on and so forth. And this list right here, I just want to be clear with you. So this list, so this, let me just say colors, unmodifiable. And the reason why I'm saying unmodifiable is that if you want to add to this list, so let's just say colors dot add, and then let's say pink. It's not that I like pink, but basically, have a look. This tells me that immutable object is modified. So if I run this, this will not work because so this list is immutable. So have a look. We have an error in here. So if I show you this method, so of, have a look, it says returns an unmodified list in here, and you could pass as many elements as you want because they have a bunch of method overloading in here. So there we go. So sometimes you need to have a list like so where you kind of just want it to be immutable. So this is how to do it. So let me just delete that, and I'll leave this here for reference if you want to have access to it. But to be honest, this is pretty much everything about array lists. If you have any questions, please do let me know. Otherwise, let's move on. All right, let's go ahead and learn about the stack. So the stack data structure is one which is very interesting. So basically it represents a last in, first out stack of objects. And the easiest way for me to explain what a stack is, just think about the pack of Pringles right here. So you see that you've got the Pringles itself. Now, if you put one Pringle inside, so let's say that you stack all the crisps right inside of the pack, right? So the last one that goes in is the first one to come out, right? Because there's no way that you can put all of them and then start eating from the bottom unless you open it, right? But basically, the last thing that goes in is the first one to come out. So it extends the vector with 5 operations that allow a vector to be treated as a stack. So you've got the push. So the methods are push, which basically allows you to push an element into the stack. You've got pop, which removes the element at the top of the stack. You've got the peek method, which allows you to see what's at the very top of the stack without removing it. So pop actually removes it, whereas peek, it just gives you the value inside. So yeah, and you've got methods such as is empty. You can basically loop through it. And to be honest, this is a stack in a nutshell. So it follows LIFO, so last in, first out. Let me go ahead and show you some code. So in here, I've got a class called working with stacks. And in order for us to create a stack, we have to say stack. And then we have to pass the type that we want to store. So here, let's say that we want to store numbers. So here, I'm going to say integer. And this will be my stack. I'm just going to call it stack equals to new and then stack. Now, the methods available within a stack are the push. So if you want to push something into the stack, you say dot and then push. So here, let me push 1. There we go. And let me push a couple of numbers. So 1, 2, and 3. There we go. So now we have a stack with 3 numbers where 3 is at the top of the stack. So if you want to find out what's at the top of the stack, you can just say stack dot and then peak. So peak will basically give you the element at the top of the stack. So here, if I just run this, you can see that we have 3, which is at the top. Now this does not remove. So let me just say first south and then stack.size. So that gives us the size. Now if I say south and then stack dot and then pop, so pop will basically at the top of the stack but also remove it. So if I duplicate the size and then print it and run this, have a look. So we have 3 right here, which is the first one when we peaked. Then the size was 3 in here, and then pop gave us back 3. So basically it removed it from the stack, and now the size is 2. So basically you can see that the API is really straightforward to use. So here, if you want to, so let me just say stack dot, and you can check whether the stack is empty, so on and so forth. So here I can say empty, and this will give you a boolean. So south. There we go. You can see that it's false because it contains still elements. Now what I want to show you is if I navigate to stack, so I want to go to this stack class, and let's have a look at this stack and then see exactly how things work in here. But this stack, have a look, it has a public method push, and in fact let me just show you so let me just collapse this and open up the structure. But have a look, the structure for this class or the methods available are push, pop, peak, empty, and search. So we can search for an element. But if you look at the implementation in here, so within the stack, whenever we say push, this calls add element. Now, where is this add element coming from? Well, let me come back to this in a second, but let's have a look at the pop right here. And you can see that this has a synchronized word, peak, synchronized, check if it's empty, search, synchronized. And basically you can see that this is a small class, but basically synchronize, this is to do when you are working in a multi-threaded environment where any access to your stack has to be synchronized. And this basically slows down the operations when working with a stack. So you have to be careful when you decide when to use a stack. Now in here, you can see that we have remove element at, add element. So these are coming from, so if I basically click on in here, show inherited, have a look. So I get a bunch of other methods. Have a look. So in here, a bunch of other methods. Now these methods, so you can see that some come from list because basically the stack is all the way back to a list, right? But what I want to show you is, so this class right here, which is the vector, right? So if I scroll up, you can see that it extends vector in here. So if I click on vector, have a look. So vector implements list right here. And if I scroll up, you can see that they have some definition. So basically the vector class implements a global array of objects. Like an array, it contains components that can be accessed using an integer index. However, the size of the vector can grow or shrink as needed to accommodate adding and removing items after the vector has been created. Now, the difference really between the vector and an array list is that you can see in here, they say vector is synchronized. Vector is synchronized. So you saw all those synchronized methods. If a thread-safe implementation is not needed, it's recommended to use ArrayList right here. So you can go through and basically you can see that this is the exact same thing as the ArrayList, but it is synchronized. So have a look, synchronize methods, synchronize trim, and a bunch of other synchronized methods. You saw that basically this ensure capacity right here, so it's also synchronized, and set size as well, capacity, so on and so forth. So there we go. So this is basically how stacks work in Java. They're very straightforward to use, and basically the methods are really peek, pop, push, and if you want to search, you can do so. Now obviously here I could say list, and then this is a stack. But now instead of saying push, I can say add in here, and add as well, and add. And basically whenever you say stack.add, what it's doing is actually calling the push method in here, right? So it's calling whatever implementation it has for the list interface. So in my case, I'm going to leave the stack like so. So this is usually how you use stacks in Java, but you know that. So if I go back to the stack class, it extends vector, and vector implements a list. If you have any questions for using stacks, please do let me know. Otherwise, let's move on. So as you saw with the stack, it follows the last in, first out, whereas with a queue, it follows the first in, first out. And basically it's a collection designed for holding elements prior to processing. Now a real world example would be, for example, if you go to a supermarket, right? So you got some groceries and you want to go and pay at the checkout. Now technically that is a queue data structure. So if you get in first, you are the first one to come out, right? If you get in last, you are the last one to come out. So basically first in, first out. Now the application usage would be, for example, if you want to build a printer, right? So a printer is a very good example. So you can submit as many pages as you want, as many documents, and then basically those elements or pages are in the queue for processing, and the processing is basically to print the actual pages. Now with queue, so a queue is an interface and you have various different implementations, but I'm going to show you one of the most popular ones, which is a linked list, and I'll also show you how it works internally. But yeah, this is a queue, and let me actually show you in code. All right, let's learn about how to work with queues. So queues right here, we basically use the interface, and here we have to use generic. So this is the type that we want. So in this case, let's just pretty much just have a static and then record. And I'm going to say this is a person. And in here, this person will basically have name and age. So I'm going to say string name, comma, and then int, and then age. So now in here, let's just say this will be the type person. And here I'm going to say supermarket equals to, and then I need to say new. And then because this is a queue, we have a couple implementations. So you can see that we have really, you'll be using most of the times a linked list or a priority queue. So let's just use linked lists, because later I'm going to show you exactly a linked list and how it works behind the scenes. So here, this right here is the implementation of this queue interface. And in fact, if I click on this and have a look, this is an interface that extends collection. And if I open up this structure, it has all of these methods right here. So add, offer, remove, poll, element, peek, and the rest come from collection. So if I go back in here, and let me just close this, open up the project, collapse this. So the way that we add someone into the queue is by saying supermarket dot and then add. Have a look. We can say add, and here I need to say new and then person, and let me just pass name and age. So here I'm going to say Alex, and let's say Alex is 21. There we go. So I can keep on adding, so multiple people. So here, let me just say Mariam, and she's, let's say 18, and then let's just say 40 here, and then this will be Ali, for example. So now we have a queue with 3 people. Now Alex was the first one to be added to the queue, so he's going to be the first one to come out. So here, if I say South, and I just want to see who's at the front, I'm going to say supermarket dot and then peak. So here, if I run this, have a look, we have Alex. So Alex is at the front. So peak pretty much just returns the element which is at the very front, but it doesn't remove. If you want to remove the person, you just say South and basically supermarket dot and then Paul. So Paul basically removes. Now you might have seen that we have, so let me just basically log, so South and then supermarket dot and then size just before, and then South supermarket size in here as well. So what I want to show you is if I run this, there we go. So you can see that we have 3. So this was the size, then peak gave us Alex, and then Paul basically returns Alex as well, but it also removes it from the queue, and then we have 2. Now the person at the front should be Mariam. So if I say South in here, and then I just want to peak, so supermarket dot and then peak, and if I run this, there we go, have a look. So Mariam now, she's next in line to be processed. Now here I'm trying to model a supermarket queue, but for example, if you want to model, for example, a printer, so this is a good data structure for it as well. Now what I want to show you is, you see that when, so let's just basically have a look at the methods in here. So Paul right here, so have a look, we have Paul which retrieves and removes the head of the queue and returns null if the queue is empty. So this is quite cool. But you also saw that if I open up the structure in here, so have a look, you saw this one here. So when I say add, you saw offer. So let's just have a look the difference between these two. So offer in here inserts the specified element into the queue if it is possible to do so immediately without violating capacity restrictions. And then it says when using a capacity restricted queue, this method is generally preferable to add, which can fail to insert an element by only throwing an exception in here. So this is quite cool, right? So you should use offer when there is a capacity constraint on your queue. So very similar to, so in here, you saw that we have Paul, and basically Paul, so Paul retrieves and removes the head if it's not null. But have a look at the remove method here. Retrieves and removes the head of this queue. This method differs from Paul only in that it throws an exception if the queue is empty, right? If the queue is empty, this will return an exception in here. So you could basically use this one Paul because it will either give you the element or null. But you know that you can use the is empty method to check whether the queue is empty or not. So let me just go back, and basically this is pretty much how you use the queue with the linked list implementation. And you can see that it's not that difficult. So this is a supermarket queue, but for example, if you want to have a printer, then maybe I should have said supermarket and then queue in here, or just simply queue, right? If you have any questions, please do let me know. Otherwise, catch me on the next one. So you saw that the linked list is one implementation of the queue interface. Now let me show you basically how the linked list works internally, and then I'll jump into code to show you the actual logic. So basically the linked list has is made of multiple nodes in a nutshell, where you've got the head. So this is the head node right here. And the head node contains, or each node contains, a reference to the next node and the reference to the previous node. Now the head right here is a special one. So the previous node for this first node points to null. But then you can see, so the second node in here, so it has a reference to the previous and it has a reference to the next. Same with this third one. So it has a reference to the previous and the reference to the next. And then you have the tail right here. So the tail has, again, the reference to the previous, and then it points to null right here. Now, basically, this data structure, it's called a doubly linked list because you've got the reference to the next and the previous. If it was bidirectional, it would have just been called a linked list. Now, each node itself contains, so the data in it is 1 and basically are integers, but this could be literally any data type that you want. So this could be a person object, it could be a car object, literally any complex data type that you have, you can stick it inside of the nodes themselves. Now, linked lists are very expensive on memory, and that's because you kind of need to know the reference to the next and the previous. So those will actually have some weight on, basically, when I say weight, I'm just saying that basically has extra space in memory. Memory these days is not a big concern, I'll be honest with you, but just so that you're aware, right? So the reference, so these two references here, so these two references, they actually need some more memory, as well as the data itself that you store within the node itself. So I can't remember exactly how many bytes each of these or the reference to each node has, plus the data itself. But depending on whether it's a primitive or an object, then obviously it will be a little bit more, right? So the memory consumption will be a little bit more. But basically, so you've got the linked list. Now what happens when you want to maybe insert, so in here, let's say that you have this doubly linked list and you want to insert 2 right here. So for you to insert a new element, what you do is you basically need to create the node itself and basically have the previous and the next. But basically, if you want to add this node right here, you kind of basically update the reference. So next will point to the new node. And then the next for the new node will point to the this node here, right here, just like that. And then we update the previous. So this one basically comes here. And excuse me for this. It's kind of difficult for me to kind of just draw like that. And so, and then you have the previous one, which will come from here, right? So the previous will point to this. And you can see that it's kind of ugly. But basically, this is what you do in a nutshell, and it represents this doubly linked list in here. Let me go ahead and show you how it works, and basically you'll fully understand this. All right, so still within the working with queues class, what I want to do is let me just extract this to a method so you have it for reference. So here I'm going to say queues, just like that, and I'm going to basically remove the invocation of this method. Now in here, to use the linked list is as follows. So here just say linked list, and let's also have a linked list of people, and here let's just say linked list equals to new and then linked list. So linked list is one implementation of the queue interface. Now if I open up the linked list class, I just want to show you the methods that it has. So let's have a look here. So at the structure, you have a bunch of public methods. So have a look: get first, get last, remove first, add first, contain, size, so node, index of, peak, and basically it has a bunch of other methods that come from DQ as well, right? So this is yet another basically interface in here. Now have a look. We have the node, so this is the pointer to the first node, and we also have the pointer to the last node in here. So remember, you saw the head and tail, so basically these are those. So here they are. Now if I show you the so let's just show you the add method in here. So add, have a look. So add, we can basically pass an element into it, and all it does, it says link last. So let's have a look at the implementation. So here basically it gets the last element or the last node, and then what it does is it basically creates a brand new node by passing L and E. So L is the last and E is basically the data, right? So the element. So if I show you the parameters, so basically L is the previous node and E is the element, and the next is null at this point. Now what it does, it says, right, so now I'm going to assign the last to the new node because this now is the last thing added, and then it checks whether it's null. If it is, then it must be a new node, so it assigns it to first. Otherwise, it assigns what used to be the last node dot next to the new node, and then it increments the counter in here. So you can see that also if you were to, so let's just say this is add, but there's also add and then passing the index. So here, check position index, and basically what it does is it does some logic whether it's not out of bounds. And if I go back in here, then basically just links the element if index equals to size. Otherwise, it links before with the element passing the node at that particular index. Now, obviously, you can go and basically read through this class. And just to show you that, as I said, if you want to get an element, so you have to traverse the linked list. So here, get, and then int in here. So this gives you the node at index. So let's have a look at this one here. So you can see that this basically, it has some logic in here, but then look, it has the loop in here, and then it checks that the index is what you are looking for, and then it assigns it to next and gives you back the node that you are looking for. So you can see that it has to loop through the list. So basically, you can go and read more about this class, but now that you know how it works, let me just show you. So here, if I say linked list dot add, you can see that I can add a person or to a specific index. And at this point, it works exact same way as the one that you see here, but I just wanted to show you how basically it works internally. So now if you want to basically, let's just have two people. So let's just say Alexa in here, and inside now, if I was to say linked list dot, and have a look, you've got a bunch of methods, but if I show you, so here we have pop, we have push, remove, to array, so on and so forth. But if I say for each, I can loop through the linked list, or I can get the iterator, so dot and then list iterator. And what this gives me is, so if I put this full screen, so this now gives me the ability to say if I want to loop front to back or back to front. So here has next, have a look, right? So if I say while and then person.iterator and then has next, so what I'm going to do is I'm going to say south and then person.iterator dot and then next. So this will give me Alex and then Alexa. There we go, Alex and then Alexa. But now if I want to look backwards, I can just say if has, so here, if has previous, and then I can get previous, or in fact, let me just copy this in here. So you see, so let me just say south, and then basically paste that in, and then has, and then previous. And here, instead of saying next, I just say previous. There we go. Now, if I run this, I should get the reverse. There we go. So now I'll go Alexa and then Alex. So you see that if you need more functionality than a normal queue, then you can use a linked list without implementing the actual interface and using the class directly. Now, one thing that you have to bear in mind is using linked lists are a bit costly because internally it uses a double linked list, meaning that there is a pointer to the next element and the previous element. So that plus the data itself adds to memory. And to finish off, because this is a linked list right here and not the queue interface directly that we are implementing, we have the option to add. So here I can say linked list dot and then add, and have a look, add last or add first right here, right? So I can add last or first, and also you saw that we can basically add to a particular index, and all the pointers to the previous and next node are changed as you saw within the implementation. So there you have it. This is linked lists in a nutshell. And in fact, let me just have basically Ali in here, and let's just say Ali is 18, and in here I'm going to say add and then last, or if you want you can add first, right? So add first, and now, so if I print this, we should see that Ali is at the very first in the beginning, and then the reverse is at the very last in here, right? So there we have it. This is pretty much how to work with linked lists. If you have any questions, please do let me know. Otherwise, catch me on the next one. All right, let me teach you about the set data structure. Now, the set is a collection that contains no duplicates. As you saw with a list, you can have duplicates, but with sets, no duplicates are allowed. And you can think of it as a bag which you don't know what is inside. And why am I saying this? And that's because the set doesn't guarantee order, right? So if you add a bunch of elements inside, and by the way, no duplicates, if you want to get them in that particular order, it's impossible. So set doesn't guarantee order, which means that you kind of have to go into the bag, and basically you kind of don't know what's inside, and you just take one bowl. In this example, let's say that you've got a bowl of different colors, and you just take one, and whatever comes is whatever you get. So basically, sets contain no pair of elements E1 such that E1 equals to E2, and at most one null element. Now, as implied by its name, this interface models a mathematical set abstraction. Now, let me go ahead and show you in code. It's really useful when you don't want to have any duplicates inside. So in order for us to create a new set, we basically say set, and right here we can basically have the type. So let's just have a static, or we can just have a record, and this will be a ball right here. So ball, and inside I'm just going to have the color. So string and then color, just like this. Now here I'm going to say that we have a set of balls. There we go. So I'm going to call it balls equals to, and then here I can say new, and have a look. We have a couple implementations. So we have the tree set, or we have the hash set. So tree set basically gives us order. So it preserves order and is backed by a tree map in here. And we have also the hash set, and this is backed by the hash map in here. And you'll learn about hash maps later. But let's use the balls with the hash map, so we don't really care about ordering. So if you want to add something to your set, you say balls dot and then add new and then ball, just like that. And then let's just say blue, for example. There we go. So now let's also add a yellow ball, and let's also add a red ball right here. So now remember I said that if you want to basically get something from the set, so if I say balls dot and have a look, I can only check whether it contains an object, is empty, to array, but to be honest, that is it, right? So if you want to basically get a particular ball in here, so if I say get, there is no get, because the order is not guaranteed, right? So just imagine a bag of balls, and if you put your hand, it's whatever you get from it. So if I use the iterator, so we can actually loop through using iterator or for each. So let me use for each here, and if I say system dot out column common println, what I want to show you is, so if I run this, have a look, we have red, blue, yellow. So even though the first ball that we added was blue, when we read it back out, the order is not guaranteed. So now we have red, blue, and then yellow, right? So yellow was actually added second, but it's given to us third. So now what I want to show you is, so if I was to add, so if I say balls, and basically you've got methods such as size, contains, and by now you should know all of these, like it's empty, so on and so forth. You also have a retain, so you can retain based off another collection. So you can imagine you have two balls and you want to retain only one bag that contains all the ones in a different bag, then that's what you use. And if I scroll down, there's a bunch of stream methods, and basically if you want to learn about streams, I've got a course on streams. But what I want to show you is, so the API is really straightforward, but if I say oh actually let me just duplicate this line in here, and if I say south balls dot and then size, if I run this, check this out, we have 3 inside, right? So even though I have this second statement here, so I try to add something, it basically rejects it. And remember I said duplicates are not allowed with sets, so that's the reason why you would use sets. So also you can actually specify your own way for how these work, but basically if I wasn't using a record, and if I was just to have a static class and then ball, and in here let's just have, so I'm going to say string and then color and have a constructor to this. So what I want to show you is the following. So if I run this now, check this out. So now the size will be 4. So why is this, right? So why is the size 4? Well, that's because in order for you to use sets correctly, you need to override the equals. So right here, I'm going to say equals. There we go. Next. And now I did override the equals method. And this is how it works with records as well. So here, let me also override it to a string method. There we go. And now if I run this, there we go. So now you can see that we are back to 3 in here. So again, if you don't override equals and HashCode, so equals and HashCode, so these two methods, comment, you'll see that even though you think that they are the same, right? So what it's actually doing is comparing the values in memory. So whether they are pointing to the same object, right? But what we want is the actual fields and properties within it. So for that, we just basically uncomment this, and there we go. So I thought I would show you this because it's really important I understand exactly what is happening. Now, obviously, so balls dot and then remove. So you can remove a ball. You can remove a ball from it. So if I was to remove this, let's just say that we want to remove the red ball right here. So if you want to remove, you just remove it like that. And if I run this, we should see only 2 balls now inside, because here it's a duplicate and we removed red. And to be honest, this is it. So if you're curious about how this works internally, I always suggest you to go and basically open up this method, for example, remove, and how it works, right? So here we have the hash and then set. So have a look. Because it's backed by a map, it just calls map.remove equals to the present, right? So if you want order to be a factor in your set, you could use so tree set in here, and also there's an enum set that you can use and other implementations. So this is pretty much how to use sets in Java. If you have any questions, please do let me know. Otherwise, let's carry on. Okie dokie. So you've learned about the collections and iterable and lists and all of those interfaces and their implementation. Now, obviously, because we're learning about data structures, I need to cover about maps, right? So maps also are one data structure that you're going to be using. And I would say you could basically use maps to solve majority of the coding challenges that you are faced with, because they are so powerful. Now, a map is just a collection of key value pairs, to be honest. And basically, so this map right here is the interface, and you have a couple implementations. So you've got the hash table right here, and you've got the hash map. So here, nulls are not allowed, and it's synchronized. So you'll see if you want to do a bunch of multi-threaded stuff, then hash tables, there's a bunch of synchronization, which slows down things. And you've got and then you've got the hash map right here, where nulls are allowed in here, and it's not synchronized in a nutshell, right? And then obviously you've got the linked hash map. So you've learned about linked lists. So basically it works based off a doubly linked list, which is a little bit slower. Then you've got the sorted map right here, which then basically this map right here, so navigable map, which then you have the tree map, which basically is just a map which is basically sorted, and nulls are not allowed as well. So this is the general overview of the map implementation that Java offers. So obviously, let's go ahead and learn about it. So as I said, a map is a collection of key value pairs. The keys cannot be duplicate, and each key can map to at most one value. So here you see that the key right here is 1, for example. So this is the number 1, and then you have a value assigned to it. Now these keys, they cannot be duplicate, and you can assign at most one value to each key. And if you come from languages such as JavaScript, an object, right? So an object is a collection of key value pairs, is the exact same thing in Java. Let me go ahead and show you how to work with maps. So to create a map in Java, we need to say map, and the map takes the key and the value. So here, let's say that we want the key data type to be an integer, and for the value, we want this to be a person. So this could be literally anything that you want. So obviously we don't have the person yet, but what I'm going to do is just say new, and then in here, let me just have the record first. So record, and then person, and inside is just going to take the string and then name, just like that. There we go. So now if I put this full screen and press Shift Control and then space, you can see that we have a couple implementations. So we have the hash map, we also have tree map, we have hash table, identity hash map, linked hash map, weak hash map, concurrent, so on and so forth. You can see that there's a bunch of them. Also, we have this interface here for a sorted hash map. But basically, we have a bunch of these implementations. And if I click on the map class, and then basically just click on this icon, and here you can see all the different implementations that I have in here, including enum map, empty map, so on and so forth. So let's just stick with the hash map. So this is the most common one. So hash map. Now for us to insert to a map, we just say map dot and then put. So here, if I say 1, and then here I need to say new and then person, and just pass the name. So here I'm gonna say Alex. So now our map has one person in it and the key is 1. So if I was to basically add key number 2 in here, and then let's just say this is Alexa, and key number 3, let's say that this one here is Mariam. Now just be aware that the keys must be different, right? So the keys, this is what uniquely identifies an element inside of this hash map. So if I now, let me just say south, and then I can say map, and I just want to see what's inside of our map. There we go. You can see that our map contains 3 entries. So this is Alex, this is Alexa, and this is Mariam. So here, if I was to duplicate this and try to add Mariam again, watch what's going to happen. There we go. So basically, you can see that it has no effect, right? So we didn't add Mariam 2 times, right? And in fact, if I was to say Mariam and then 2, what's going to happen is the latest insert in here will override the key that you have initially provided for Mariam, right? So be careful. So the keys must be unique, otherwise you'll be overriding things. So with the map, we can basically check how many elements we have inside by just saying in here, we can say south, and I can say map dot size. We can also get D, so map dot, and in here I can get, so I can say get, and this is based on the key, so key number 1, and this should give me Alex. We also can, so south and then map, and in here we can check whether it contains the key or not. And then let's say 4, we know that there is no one with key 4. So let me just also say south dot, and here we can get the entry set in here. So entry set, this will give me all the entries. We can also get the key set, so map dot and then key and then set. Let me just swap these around and let me just run this so you can see what we have. So there we go. So you can see that the size of our map is 3. We say get 1, so this is Alex. We said contains key 4, this is false. And then the key set, you can see that this gives me back a list of numbers. And then we have the entry set, which basically just gives me the entries in our map. So obviously you can basically then loop through. So I could say, for example, map dot entry set dot and then for each, and I could say system dot and then out colon print line, and what this gives me is basically all the entries. So this contains the key and the value. So if I was to in here replace with, so if I just replace with a lambda instead, so here I could say x dot get key plus and then plus x dot get value. So let me just put this on a new line. So basically what is happening now is you can see that we do have this loop where we looping through each element by getting the key as well as the value. So you could also loop by saying map dot for each, and this takes the integer, which is the key, and then the basically the value itself, right? If you don't want to use the entry set, so you could do it this way right here, where I can say south and then integer, so that's the key. And in fact, let me just rename this to key, and then plus, and then plus, and then the person itself. So if I run this, you can see that this should also work. There we go. So this is the second loop in here. You can also delete from the map. So here you could just say map dot and then remove. And to remove, you have to pass the key that you want to remove. So here, let's just say that we want to remove 3. So 3 was Mariam. So if I run it, you should see that. So initially she's in here, Mariam, but then we deleted it and she's no longer in here when we loop through the map. So you can see that the API is quite straightforward. You can also say map dot, and you can have these compute if absent, which takes the key and then the function. So this is whatever you want to perform if the key is not present, or if you want to compute if the key is present, then you can do so. If you want to remove everything from the map, you could just say dot clear. This gets rid of everything from the map. You've got get or default. So in here, so if I was to say south and then map dot get, and then we know that 3. So we've deleted Mariam. So if I run this, you can see that this gives me null, but you can say dot and then, oh, actually not dot, but get or default, and then you can specify the default. So 3 is what we're looking for, and if it's not present, I'm just going to return a brand new person, and I'm going to say default. So run this, and instead of null, we should get the default person in here. So the API is quite straightforward to use, and there's a bunch of other things. So replace all. If you want to get all the values, so without the keys, you could just say south and then map dot and then values. I think I've showed you the keys as well, right? So where is it? Yeah, so key set in here. And if you want just the values, this is how you do it. And in here, let me see if there is keys. All right, so yeah, so it's called key sets. I've showed you already the key sets, and you've learned about sets. You should know that with sets, there shouldn't be any duplicates in it. So hence a set. So if I run this, there we go. So you can see that these are all the values. So Alex and Alexa. So this is pretty much how to work with maps in Java. Next, I want to cover something which is really important that you should know when working with maps. Okie dokie. So let me go ahead and show you what exactly is the hash code and hash functions, what they mean, and how they're super useful when working with maps. So when we say map.put, we have to pass the key, and you saw that we could use basically, if you want an integer, you just pass an integer and the keys cannot duplicate, right? Now, this key right here, it goes through what is known as a hash function. And a hash function basically is a function that produces something known as the hash code. Now, what the hash code really means is mapping an object to its integer value. Now, you can call the hash function on the same object and it will always produce the same hash code. It will always produce the same hash code. Now, internally, when you basically say map.put and then 1, so 1 goes through the hash function. It produces the hash code. In this example, here it's 1, and then it stores 1 and then the value associated with it. Now, for integers, the hash code is the number itself, and you'll see this in a second. But for example, if you were to say map.put and a new person, Jamila right here. So this new person, Jamila, goes through the hash function associated with it. It produces the hash code. And in this example, you can see it's -2083476985. And basically this integer right here, so this negative integer right here, is what maps to this person right here called Jamila. So I can call the hash function on this person 1 million times, and it will always produce this hash code right here. And this is what internally the hash map or all of the map implementations use internally, right? So it's not efficient for it to use, for example, the object itself to perform the key lookups. So with maps, lookups are very, very fast because of the hash code. And obviously there's a lot more to these hash functions and hash codes, but this is in a nutshell how it works. Now, obviously, I'm going to show you exactly why do you need to override the hash code. So this is something that I've mentioned before, but I didn't actually explain, but let me go ahead and teach you why you need to override the equals and hash code on your classes. Let's go ahead. So to demonstrate this, what I'm going to do first is let me just extract this so you have reference to it. I'm going to say maps, and in here, what I want to do is I want to have a new map. So I'm going to say map. And now what I want to do is I want to switch the keys for a second. So here, this will be a person right here. And let's say that each person has a diamond. So here, let me go and create the record. So this will be a record and then diamond and then string name. There we go. So we have the diamond in here, and I'm just thinking out loud. So here, this will be a map equals to new and then hash map. There we go. Now let's add a person. So map.put new and then person. And let's say that this is Jamila, for example, and Jamila has a diamond. So new and then diamond. And let's say that this is an African diamond. So African diamond. And to be honest, I know nothing about diamonds. So there we go. So now we have this map that has one person, which is the key, and then the value is the diamond. Now, what I want to do is, I think you've seen this. So let me just change this from a record to a class. So class, and inside I'm going to have the string and the name, and add this to constructor. There we go. Let me also override the toString, and there we go. And also, so in here, I need to make this static. So let's just make this static, just like that, and the errors went away. Now, so I just want to show you that what happens is if I say south and then map dot and then get new person and then Jamila. So let's see what's going to happen here. So I'm going to run this and check this out. We have null. What is happening here? So we kind of have this key right here, which is person. But when we say map.getNewPerson and then Jamila, so this is actually saying that there is no one with that key. Well, we know that there is, and that is Jamila right here, but we are missing something very important, and that is to override the hash code. So usually if you use records, all of that is provided for you by default, but what we have to do is we have to basically say hash code right here. There we go. And by default, the contract is if you override the hash code, then this will also override equals. So equals is when you want to compare whether two objects properties are the same. So all the properties, and then this hash code right here, this is what internally is used for the hash maps. So this is the hash function that returns this hash code right here. So this comes from objects.hash. And if I look at the implementation of this basically looks at the arrays.hash. Let's just follow that through, and you can see the implementation right here. But basically what is happening now is, so if I say, let's just basically do this. If I say south in here, and then let me just grab this line and then paste it here. So this is basically, these are two objects which are completely different, right? But if I invoke the hash, so let's just invoke the hash code on these objects. So hash code. So these, they'll be the same no matter what. And this is what's internally used whenever we basically want to find a person. So basically it takes the person, it gets the hash code, and then it looks up. So it performs a lookup on the hash and never on the object itself. So if I run this, I just want you to see that. There we go. Have a look at the hash code. The hash code will always be the same. Have a look. So this is the hash code. And right here, we no longer get null, but we do get the diamond associated with this person in here. So if I just, for a second, so let me just remove this and then run it again, you'll see that this will break. And have a look at the hash code. So now, even though they are two exact same objects, right? So new and then Jamila. So here, have a look. So new Jamila and new Jamila. So these are basically identical, but because we didn't override the hash code, so what it's doing is, so again, everything is an object in Java. So if I click on, so not here, but if I click on structure and then basically click on hash code, have a look. So this will be implemented in subclasses, right? So if I click on it, you'll see that there's a bunch of things which are inheriting this, but by default, if you don't override, then the hash code will be different. So if I go back in here, and the reason why it works with integers, so with integers, for example, you don't have to override any hash code, and that's because, so let me just collapse this. So that's because with integers, so let's have a look with integers. So here, if I look for the integer class, so integer, and in here, have a look, we have the hash code. So this is a method which gives us the hash code, and by default is just the number itself. If we look into the string class, so string, have a look, the string class, it's a little bit different. So the implementation is a little bit different, and you can see that this will just ensure that for any given string, if they are the exact same content and value, they will produce the exact same hash code. So hopefully now you are pretty much aware of how to use maps, and just remember that you need to always override the equals in hash code. So equals is for equality, and this is to be used within the map itself, so that for any given identical object, they will always return the exact same hash code. So to be honest, this is it. If you have any questions on maps, please do let me know. And also, as I've said, there are other implementations. So here, new, and then have a look. We have a sorted map, we have hash table. This is actually an interface, but we have hash table. We also have linked hash map, weak hash map, concurrent for concurrency, and others. So if you have any questions on hash maps, drop me a message. Otherwise, catch me on the next one. Okie dokie. I hope that now you have a complete understanding of the data structures that the Java programming language has to offer. So I would say lists and maps are the ones that you're going to be using most of the time, unless you are working within a multi-threaded environment. But I would say lists and maps are the ones that you're going to be using most of the time. And to be more precise, lists, right? Because these days memory is not a concern. If you need more resources, you just spin up a new pod or a new EC2 or a new VM somewhere in the cloud. If you're new to my channel, go ahead and subscribe. Give me a thumbs up so I can keep on recording these videos. Also, If you're not part of the Amigoscode community, join both the private Facebook group as well as Discord. The community is growing. And yeah, that's all for now. And let me know also what you want to see next. I'll catch you in the next one. Assalamu alaikum.